Okay, in this video, we're going to cover absolute value functions when they intersect the x-axis. And so we're going to determine the number of times the equation will intersect the x-axis. And so let's begin. Now this will be the first problem. So if it intersects the x-axis, that means the y value is 0. So our first step is to say is equal to 0. Then we want to have the absolute value to be by itself, so I'm going to add 2 on both sides. Plus 2 plus 2. And so we get the absolute value of x squared plus 3x, close it, is equal to 0 plus 2 is 2. At this point, I'm going to split it up, because if this wasn't here and I had the absolute value of negative 2, it's also equal to 2. Likewise, the absolute value of positive 2 is also 2. So we're going to have one version where it's a straight copy without the absolute value sign, and then the other version is going to also be a copy, but we change the 2 into a negative 2. Because again, absolute value of negative 2 is equal to 2. So now we're going to subtract 2 on both sides. And here we're going to add 2 on both sides. And so we get x squared plus 3x minus 2 is equal to 0. Here we get x squared plus 3x plus 2 is equal to 0. Now in this problem, we don't actually care where they intersect. All we want to know is the number of times. And so we can use a discriminant. So the discriminant is b squared minus 4ac. And if the discriminant is positive, we get 2 real roots. So 2 instances where it crosses the x-axis. Now if it's 0, we're going to get 1 real root. So it'll cross the x-axis once. And if it's a negative number, it'll have no real roots, so it won't cross the x-axis. So we're going to figure out the determinant for this piece and this piece. So the a value here is 1. It's the coefficient in front of the x squared. B is 3. C is negative 2. Likewise, same procedure for this. So b squared, so we get 9. 3 squared is 9. Minus 4 times a is 1, and c is negative 2. So we're going to get negative 4 times negative 2 is a positive 8. 9 plus 8 is 17, so we get a positive number. We don't even care about the number. Then we'll do this piece. B squared minus 4ac, and b is 3. 3 squared is 9. Minus 4 times a is 1, and c is 2. We get 9 minus negative 4 times 2 is negative 8. And so we get a positive 1. So still a positive number. Because both of them are positive, we're going to get 2 real roots plus 2 real roots. So how many times does the equation intersect the x-axis? It'll be 4 times. And I'll also visually show you this. So if we were to graph it, we get 1, 2, 3, 4. And now we'll do our second problem. Same procedure. So if you want, pause the video here and attempt it. So I'm going to set equal to 0 because if it crosses the x-axis, that means the y value is 0. Then I'm going to add 4 on both sides. And so I get the absolute value of x squared plus 3x, close it, is equal to 4. And then we split it up. So x squared plus 3x is equal to 4. And x squared plus 3x is equal to negative 4. And now we're going to subtract 4 on both sides. And here we're going to add 4 on both sides. And so we get x squared plus 3x minus 4 is equal to 0. Here we get x squared plus 3x plus 4 is equal to 0. Again, we have to do the discriminant, so that's b squared minus 4ac. Again, no coefficient, so we know it's 1. No coefficient, so we know it's 1. b squared, so we have 3 squared, so we get 9 minus 4 times a is 1, and c is negative 4. Likewise, b is 3, and 3 squared is 9, minus 4 times a is 1, times c, which is 4. Okay, so we have 9, negative 4 times negative 4 is a positive 16, so we get a positive number. And here we get 9 minus negative 4 times 4 is negative 16, so we're going to get a negative number. So this piece tells us 2 real roots, this piece tells us no real roots, and so our final answer will be it will occur 2 times. And again, I'll show you a visual of it. So if we were to graph it, this is what we would get. So it occurs 1, 2. And that's pretty much it for this video.